Now question number 5. Miscellaneous exercise question number 5 এ বলছে যে find the sum of integers from 1 to 100. From 1 to 100 the which are divisible by 2 and 5. We have to find out those sum of those numbers which are divisible by 2 or 5. And those integers between means actually from 1 up to 100. From 1 up to 100 the numbers from 1 up to 100 which are divisible by either 2 or 5, we have to find out the sum of those numbers. Now let's start. So first of all we have to check whether the number is divisible, which numbers are divisible by 2 or which numbers are divisible by 5. So as we know that the numbers divisible by 2, numbers divisible by 2 are 2, 4, 6, 8 in this way up to 100, because we are considering only those numbers which are divisible by 2 from 1 to 100. We do not go beyond the numbers 100. So these are the numbers which are divisible by 2, only 2. Now sum of the sum of these numbers is equal to 2 plus 4 plus 6 plus 8 plus up to 100. Now what is the sum of these even numbers? So this sum is equal to, so how many numbers are there in this series? It is clear that there are how many numbers? There are 50 numbers total, because the last number is 100. So if I take tn is equal to 100, then this series is an AP series with first term 2 plus n minus 1 into d is also 2, common difference 2. So this is equal to 100. Now this implies that n minus 1 into 2 is equal to 100 minus 2, that is 98. That is n minus 1 is equal to 98 by 2. N minus 1 is equal to 449. That is n is equal to 50. That means we just consider that there are n terms in this series. So if there are n terms, then the last term, that is nth term, is equal to 100. And from this equation we solve for n and get n equal to 50. That is, we have 50 terms in this series. So sum of these 50 terms is equal to 50 divided by 2 into first term plus last term. That means 50 by 2 into 102, dividing this we get 50 into 51. So how much we get here? 0, 5, 25. This one. This is the sum of the numbers divisible by 2. Now we now consider the numbers divisible by, now this term 2550, this is the sum of even numbers. Now we consider the numbers or integers which are divisible by 5. Numbers divisible by 5 are 5, 10, 15 dot 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 up to 100. Now what is the sum? Therefore the sum is equal to what? Sum is equal to 5 plus 10 plus 15 plus dot 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 100. So how many terms in this series we have? To calculate, we take Tn is equal to 100, and here first term is equal to 5, common difference 5, n minus 1 into 5 is equal to 100. So n minus 1 into 5 is equal to 100 minus 5, 95. That is n minus 1 is equal to 95 by 5, 19. That is n is equal to 20. So in this series we have 20 terms. So sum of these 20 terms is equal to 20 divided by 2 into first term plus last term. That is 10 into 105. That is 1050. This is generally this is what? This is the sum of the numbers divisible by 5. Now we now consider those numbers which are divisible by both 2 and 5. Out of these numbers, there are some integers between 1 and 100 or from 1 to 100 which are divisible by both 2 and 5. So we have to consider these numbers which are divisible by both 2 and 5. Both 2 and 5. So here in this case the numbers divisible by both 2 and 5 are 10. A number which is divisible by both 2 and 5 means the multiple of 10, because the LCM of 2 and 5 is equal to 10. The numbers which are divisible by both 2 and 5 are those numbers which are divisible by 10, which are divisible by LCM of 2 and 5. That means that 10, 20, 30 dot 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 up to 100. These are the numbers which are divisible by both 2 and 5. And these numbers already occur in and these numbers are all even numbers, and these are all divisible by 2 and also divisible by 5. So these numbers also occurs in the numbers divisible by 5 and also in the numbers divisible by 2. So what is the sum of these numbers? Now here the sum is equal to 10, 20, 30 plus dot 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 up to 100, and this sum, and how many terms? Here we have only 10 terms. It is clear. So 10 divided by 2 into first term plus last term, that is 10 by 2 into 110, so 5550. Now the required sum means the numbers which are divisible by either 2 or 5 is actually the sum of the numbers divisible by 2 and the sum of numbers divisible by 5 minus sum of the numbers divisible by both 2 and 5. The required sum, therefore the required sum is equal to the required sum is equal to numbers divisible by 2 plus numbers divisible by sum of the numbers divisible by 5 minus sum of the numbers divisible by both 2 and 5, it is 550. So here we have 2550 and subtracting this we get 500, and finally we will get 0 5 5 5 5 plus 5 10 0 okay 1 3 0 5 0. So this is the number. So we subtract here the sum of the numbers divisible by both 2 and 5 because these numbers occurs once in the divisible in the multiple of 2 and in the numbers multiple of 5. So it is already occurred twice, once in the divisible in the multiple of 2 and once in the multiple of 5. So we subtract the one, we cannot repeat these numbers, and that is why we have to subtract the sum of the numbers divisible by both 2 and 5, this one.